The idea that our universe is a highly sophisticated, multi-dimensional digital simulation is no longer confined to the realm of science fiction or ancient philosophy. In 2026, the simulation hypothesis has transitioned into a serious field of study within quantum mechanics, astrophysics, and theoretical computer science. As our own computational power expands exponentially, leading cosmologists and physicists are turning their instruments inward, searching for the literal source code, pixel boundaries, and glitches built into the fabric of space and time. We are approaching a profound scientific realization. The universe behaves less like a collection of solid physical objects and more like a massive, self-rendering holographic software environment. The mathematical arguments supporting this theory are deeply rooted in the fundamental constants of nature. First, consider the absolute speed limit of our reality, the speed of light, which sits at exactly 299,792 kilometers per second. In the context of computer engineering, this is not an arbitrary physical law. It functions precisely like the maximum processing speed of a hardware processor, or the rendering limit of a game engine. Information cannot travel faster because the underlying computational substrate of reality cannot compute it any faster. Furthermore, our space-time continuum is not infinitely smooth. Quantum mechanics dictates that reality has a minimum pixel size. The Planck length, measured at a microscopic 1.6 times 10 to the minus 35 meters, and the Planck time, at 5.4 times 10 to the minus 44 seconds, represent the absolute smallest units of space and time possible. If you try to look deeper, physics completely breaks down. This cellular structure perfectly mirrors how a high-definition digital screen works when viewed under a microscope. The second major proof comes from the bizarre laws of quantum superposition, famously demonstrated by the double-slit experiment. In quantum physics, subatomic particles exist only as a wave of mathematical probabilities until a conscious observer or a measuring device interacts with them. The moment observation occurs, the wave function collapses into solid physical matter. This mechanism is identical to the optimization algorithms used in modern open-world video games. To save processing power, a game engine does not render the terrain or objects behind the player's back. It materializes them only when the character turns around to look at them. The universe appears to perform the exact same data-saving routine on a cosmic scale. The timeline for testing this hypothesis is moving faster than most realize. By 2030, experimental physicists plan to deploy ultra-precise space-based interferometers to detect whether space-time exhibits microscopic holographic noise at the Planck scale. Concurrently, theoretical physicists like James Gates have already discovered actual browser-like error correction codes embedded directly within the mathematical equations of string theory, which describe the core mechanics of our universe. By 2040, as human engineers build the first planet-scale quantum computers capable of simulating billions of conscious digital entities, the statistical probability that we are the original, baseline biological civilization will drop close to zero. If we can create simulated realities within a few decades, it is almost mathematically certain that someone else already did it to us millions of years ago. We are officially standing at the edge of the ultimate paradigm shift. Reality is not composed of matter, but of pure information.